Uh, Nice to meet you all in the room. Hello. I'm Shanbor. I'm a principal with Clean Energy Ventures. We're an early stage fund, typically investing in seed Series A, with an investment criteria around emissions reduction and impact. We have, across two funds, we have 27 investments, I want to say, right now. First fund was 110 million. We just announced our second fund, which was 305. And we've made about 7 investments out of that, including into Andrew's company called OXCCU in the sustainable aviation fuel space. And I'll let Andrew do a quick introduction.
Yeah, thanks, Shanbor, and good to see you all. My name's Andrew Symes. I'm CEO of OXCCU. So we're a spin-out from Oxford University, one of Clean Energy Ventures' first investments this side of the pond. And we're focused on novel processes that reduce the cost of sustainable aviation fuel. And I can say a little bit more about that in a bit as we get into the discussion.
All right. So I thought for this chat, and keep it relatively informal. We don't have slides, as you can see, but more just about what are the different pathways? What are hydrocarbons, for example, and why are they important? What are they used for? And are they going away anytime soon, Andrew?
I mean, this is the kind of point I think that people need to recognize is that you can't eliminate all hydrocarbons, even in a net zero world. There is a residual demand for them. You essentially can electrify as much as you can, of course. For efficiency reasons, there are benefits to that. And where possible, you can potentially use hydrogen directly. But hydrogen use is challenging for many sectors. Potentially steel and ammonia, you can use hydrogen directly. But there are many, many circumstances where you need the combination of carbon and hydrogen, not just hydrogen. The 3 most obvious sectors that I don't think anyone debates is aviation fuel, where the energy density requirements to get over the Atlantic or other large distances is so significant that you need the combination of carbon and hydrogen in a molecule. And also chemicals and plastics. In those 2 sectors, you have to have carbon. It is the product. You can't substitute that with just hydrogen. So there are these chunky sectors that remain, and the question is, where are you going to get them from? And I guess the first kind of attempt at solving that was the biofuels. Have you made any biofuels investments, Shanbor? Or
not yet, but we invested in a company called out of our first fund called Clear Flame Engines. They basically retrofit the diesel engine to run on ethanol, methanol, and other fuels. So for certain applications, for certain aspects, like as Andrew mentioned, the chunky sectors, that's where I think biofuels makes sense. But what about for aviation specifically? How do you see it?
I mean, biofuels can definitely play a role, but the challenge is when you base them on crops, you've got limitations due to land use. So in the US, generally, ethanol is made from corn, and in Europe, it's vegetable oil. Vegetable oil is generally actually imported at the moment from China. The challenge with scaling that further is that you need a huge amount of land, and we just don't have it. We need the land for growing food. We need the land for biodiversity. So then you're into kind of waste-based fuels, but they're all problematic, whether or not it's kind of aggregating the feedstock, sorting the feedstock, converting the feedstock. You've got significant problems, and you're still reliant on essentially, the growth of the biomass, to essentially, recover it. Plastic waste is an option, but it's extremely difficult and not an easy feedstock to work with. So, the question is for us, kind of what do we think the answer is? Well, we think the answer is using CO2. So we can use CO2 to make the fuel. So the combination of CO2 and hydrogen in the fuel can be the answer. So what's called CO2-derived fuels or power-to-liquids. And if you look at sustainable aviation fuel, as you asked, Shanbor, generally people are thinking about vegetable oil-based, maybe some ethanol-based, maybe some plastic or carbon waste-based, and then a huge chunk in the future to be CO2-based fuel. So what's called power-to-liquids or e-fuels. And the reason for that big chunk is because we can have more confidence in the feedstocks being available. The feedstocks being renewable energy and carbon dioxide.
So we clearly feedstock is the word of choice, but how do we think for e-fuel specifically? What are the challenges, especially around cost and feedstock availability? How do you, and logistics around it? You still have to do some. How do you think about that going forward?
Yeah, I mean, we've still got feedstocks, right? There's just, potentially more abundant. You're right. The challenge with e-fuels is cost, and the solutions that people are looking at are really trying to get the cost down. Now, why is cost a challenge? Well, Saudi Arabian oil comes out pretty cheap, and we're trying to compete with that. It's difficult. But at the moment, we are reliant on technology curves coming down in a number of key sectors. So the most important being renewable energy, but the second, electrolyzer industry. And then where we come in as OXCCU is we're focused on simplifying the process to convert CO2 and hydrogen into fuel. So essentially, we are turning a two-step process, which currently everyone is focused on, which goes via carbon monoxide, and we're simplifying that into a single step. And that gives us this ability to get much closer to parity with fossil fuels, and so we can start displacing more and more and more, and people can keep flying.
Well, that's it's interesting in terms of, do you see, so you mentioned other feedstocks and cost being the challenge. So do you see the other pathways like, waste, etc.? Do you see them ever hitting cost parity? Is that, is that feasible? Is it, certain applications, how should we think about that?
It's a tricky one because, I mean, when people say cost parity with fossil, I mean, people aren't including the huge damage that's going to come from climate change because we use fossil. So if you include, say, the cost of Mexico City running out of water, or the cost of large parts of, countries not being able to grow crops anymore because of climate change, then obviously you've got something else to kind of counter it. But if you, say, don't tax the carbon, the emissions, and pay, then yeah, it's difficult competing with oil or certain types of oil. I mean, it does vary. I mean, if you're competing, say, with tar sands from Canada, it's a lot easier than competing with oil from Saudi Arabia. But that said, what I always think is we need to get within a range that the regulator can essentially step in and say, no, you've got to buy this, not that. And I always think that's kind of roughly 2 times fossil, or maybe 3, but any more than that is very difficult to get the consumer to pay. The other thing I would say is the consumers actually can cope with gradual price increase. They can't cope with sudden shocks, like with Russia's invasion of Ukraine. Prices go up, say, by 3 times. The government then immediately has to step in and basically subsidize. That's a fact of going from, say, I don't know, a certain price and then 3 times it. If you steadily go up, people can cope with that. We've done that with gasoline. Gasoline has like 10% ethanol. Ethanol's very expensive, but everyone doesn't know that when they fill up their car, some of it is ethanol. People just accept that. They're not even aware potentially of that being the case, but they're comfortable with it. So I do think this conversation around parity is important. The key is, can you get within range, and then it's easy decision for the government, the regulator, to step in and say, actually, you need to stop doing the fossil because of the climate change, and buy this. It's not that much more, and we'll make sure that the price increase to get there is gradual and not immediate.
And so you've been saying, regulators. Have you seen what's the general kind of high-level regulation tailwinds, headwinds coming up across the space in aviation, at least?
I mean, we've seen a huge amount in the last just 2 or 3 years even. So the US has got the IRA, there's big subsidies now around sustainable aviation fuel. In Singapore, they've announced some subsidies, but most exciting are probably the EU and the UK. Both have mandates on the fuel suppliers to buy a certain amount of sustainable aviation fuel by a certain date. If you don't supply it, then you then basically have to pay a buyout price. It's significant. So they're all incentivized essentially to have to build plants to produce a certain amount of sustainable aviation fuel. And we're talking about relatively small numbers in the first kind of 28, 29, 30, 31. But beyond that, it gets large. So, this industry is nascent, but it's going to grow very rapidly. The numbers on people wanting to fly are actually crazy. I mean, going up so fast, and especially when you look at Asia, the growth rate there is incredible. And everyone is using jet fuel. They're not using eVTOLs, or they're not using hydrogen planes. They're all using the existing aviation fuel planes.
So customers must be scrambling to kind of get SAF in place, or available. So how does that relate to you? Where do you stand in terms of supplying to them? Where are you now? What are you going to get to?
Yeah, so we're currently doing our kilo a day plant. So it's early days. That will be in Oxford Airport. It's a demonstration plant, but we're already quickly moving to our 200 litre a day, which will be in Humberside. And then we're planning 28, 29 is be when we plan to have our commercial plant up and running. Again, if it's in the UK, most likely Humber or Teesside, but we're also looking at places globally. At the moment, you've got to go anywhere, for e-fuels at least, you've got to go for anywhere where there's, good green power, and that's really kind of the key feedstock that we need. So the UK with offshore wind, certain countries, like the Nordics, especially if you've got a bit of nuclear, a bit of hydro in there, like Quebec's looking quite interesting. South America with the wind, and some places with solar as well. But it's not for everywhere. If you haven't got a green grid, this isn't for you. You need to green your grid first, because literally no point. You need to get rid of coal and start greening that grid, and then you're going to have this surplus of green energy. Use that to basically make hydrogen. Hydrogen's not a good commodity. Maybe some uses, it can be used direct, but generally not. Then combine it with CO2 and make fuels. And we've got a valuable product. We know we can trade, we can store, we can use an existing infrastructure.
No, it sounds like timelines are aligning as grids get greener. You start scaling even further. So, well, with that, I don't know how much time exactly we have left, but I thought if folks have questions, again, keeping it informal, feel free to raise hands.